method of finding principal stresses, compound stress problem. We have done this by deriving the equation. Analytical method we have done. So this comes in module 2. So today we will see how we can calculate or obtain the principal stresses and the principal planes by graphical method, which is known as Mohr circle method, M-O-H-R, Mohr circle method. So we have done problems like this. If you remember, we have done problems like this. So normally stresses will be given in x direction, in y direction. They can be either tensile or compressive. So tensile stress away from the object. So if the arrow is going away from the object, then it is tensile stress. If the arrow is coming towards the object, it is compressive. And shear will be acting like this. Okay. So this I have written as sigma x. This I have written as sigma y. And this has tau. Or in some books they take it as q. So this is what we had explained. Now, how to find? So there are two types of problems in this. Both the problems we have done using analytical method. Today we will discuss how it can be done method. So one type of problem is this is given. That means this sigma x is given. For example, here is sigma x is 65 Newton per mm square. It is tensile. So tensile stress is taken as positive, compressive stress is taken as negative. Then this is sigma 2, which is nothing but your sigma y. Okay, so this is sigma x. Sigma x is 65 Newton per mm square tensile. Sigma y is also tensile. It is 35 Newton per mm square. And the value of tau is nothing but shear stress. So here shear stress always acts in the complementary manner. That means if I take the shear stress like this, on the other side, it will be in the opposite direction. See, it is acting towards left here. On the other side, it acts to the right. And here, on these two sides also, shear stresses will be acting. And how they act? So here, it is acting towards left. So it should act upwards, so that this arrow and this arrow should meet. Similarly, on the other side, it will be acting downwards. This arrow and this arrow, they will meet. So shear stress will be acting on all the four edges. Tensile stress or compressive stress will be acting perpendicular to the edges. So please note that this I have taken it as sigma 1. This I have taken it as sigma 2. So sigma 1 here is 65. Sigma 2 is 35. Tau is 25. So it is equal on all the four sides. So if the stress is tensile, it is taken as positive. If the stress is compressive, it is taken as negative. Shear, you can take it as positive. So in this problem, major principal stress, so major is actually it is not, you can call it as sigma x. Sigma x means it is acting along the x direction, which is taken as 65 Newton per mm square. And sigma y is taken as 25. Where is that? So already we have discussed the analytical method of finding principal stresses and principal strains. Today we will see the graphical method, which is also called Mohr circle method. So which is done on a graph sheet. So understand how to draw the graph and how to obtain the value of the principal stresses from the graph. That's what we are discussing today. So here, please note that instead of taking it as sigma 1, sigma 2, you can just take it as sigma x, sigma y. So that is the same convention we can use. Sigma x is this in x direction. Sigma y is this in y direction, and this is tau. Tau is the shear stress. So these things will be given, and they will ask you to find the normal stress and shear stress on an inclined plane, oblique plane like this. Here in this problem, that oblique plane is given as 45 degrees with the vertical. So this type of problem we have done analytically. Actually, the formula, so in the exam they can ask you both. Check the answer, you have to, he may ask you to do by Mohr circle method. Then he may ask you to check the answer by analytical method. So to check the answer by analytical method, you should know the formula to find the normal stress and shear stress on the oblique plane. So formula I will show you here. So this we have derived already. Yes, this is the formula. You can make a note of that formula. Yeah, see here. When a member is subjected to two direct stresses means that is sigma x and sigma y, tensile or compressive, in two mutually perpendicular directions, that means x and y directions, accompanied by a simple shear stress tau. Then the stresses on an oblique plane inclined at an angle theta with the axis of minor stress are given by. That means that theta is measured with the vertical. I showed in that diagram, you know. Then the normal stress on that oblique plane will be given by sigma n is equal to sigma 1 plus sigma 2 by 2. So that means sigma x, you can take it as sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau into sin 2 theta. This equation actually we have derived. So I had explained this in the lecture notes provided to you. You can call it as tau also. Sigma x minus sigma y by 2 into sin 2 theta minus tau into cos 2 theta. So these two formulae you should remember. Okay, making an angle theta with the vertical. So this you can find out using the Mohr circle method also. Now the angle is given by position of principal planes is given by tan 2 theta is equal to 2 tau divided by sigma x minus sigma y. So please note that wherever sigma 1 is there, you can take it as sigma x. Sigma 2 you can replace it by sigma y. And sigma x is positive if it is tensile, sigma and negative if it is compressive. Similarly, sigma y is positive if it is tensile and negative if it is compressive. So that is the sign convention we are going to adopt. And we have derived this formula for major principal stress. The principal plane means it is the plane on which shear stress is zero. So all this I have defined earlier. Major principal stress is given by, actually I have used sigma 1 for major principal stress, sigma 2 for minor principal stress. So that's why I told you to replace the sigma 1 by sigma x and sigma 2 by sigma y. So major principal stress sigma 1 is given by sigma x plus sigma y by 2 plus square root of sigma 1 minus sigma 2 by 2 whole square plus tau square. And minor principal stress is given by sigma 2, which is given by sigma x plus sigma y by 2 minus root of sigma 1 minus sigma 2 by 2 whole square plus tau square. So the difference between these two is this is plus, this is minus, that's all. Okay. And maximum shear stress is given by half into root of sigma x minus sigma y whole square plus 4 tau square. So these are the formulae we should remember when you are doing the same problem by analytical method. When you want to compare the value by both the methods, you should know these four formulae. So two types of problems will arrive. One is given sigma x, sigma y, tau and theta, you are asked to find the normal stress sigma n and shear stress sigma t on that inclined plane. Another type of problem is, once again given sigma x, sigma y and tau, we have to find out the principal stresses and the directions of principal planes. So there will be two principal planes. If you, this is the formula used to find the angle made by the principal plane. So tan 2 theta. So you will be getting actually two values of theta here. So one value differs the other value by 90 degrees. If one value is 70 degree, Another angle will be 70 plus 90, which is 160 degree like that. So that is what we have discussed earlier. Now we will see how the same problem can be done using Mohr circle method. I am going to explain using this problem. All of you be attentive. So afterwards, you have to practice this on a graph sheet, plain graph sheet, and you have to check the answer. I am going to explain now how to do this problem by Mohr circle method. So here you can see sigma x is 65, sigma y is 35. Both are positive because both are tensile. And tau, whether they give like this or like this, you don't worry. Tau is always positive. So 25. Tau is 25 Newton. All are in Newton per mm square. Now the question is, what is the normal stress and the tangential stress or shear stress on this oblique plane? So normal stress, direct stress, they are same. Tangential stress and shear stress, they are same. So there are two words. Now, according to the method, all of you observe here. Now I have written the data now. Instead of sigma x, I take it as sigma 1, I take it as sigma x. So here sigma x is 65, sigma y is 35, tau is 25. You have to choose a particular scale for drawing the Mohr circle. So depending on the values of the stresses given in the problem, you can choose some scale. So now let us choose 1 centimeter is equal to 10 Newton per mm square. If I take 1 centimeter is equal to 10 Newton per mm square, sigma x will be 6.5 centimeter, sigma y will be 3.5 centimeter, tau will be 2.5 centimeter. So that is the conversion on the graph. Now the procedure I am going to explain now, all of you be attentive. Draw a horizontal line like this. Okay, draw a horizontal line from A. Now on this line, AM, let us say AM is the line. On this line, mark the tensile stress values which are given. Sigma x and sigma y, you have to mark on this. For example, sigma x is 6.5 here, sigma y is 3.5. So take 6.5 centimeters from this point A. So this C here. So this is 6.5 centimeter, that means 65 Newton per mm square according to the scale. And this is 35. So AB represents sigma x, AC represents sigma y. So please note that both are in the same direction. AB and AC, they are in the same direction because both are tensile. Both are tensile. If one is tensile, another is compressive, then you have to plot on the other side. For example, if this sigma y is compressive, then you have to measure 35. From this side, you have to measure to the left, minus 35. Okay, left side you have to measure. Since both are positive here, 65 and 35 both are positive, you have to draw to the right side. So that is first step. So take any point A and draw a horizontal line through A. Take AB is equal to 65 Newton per mm square, 6.5 centimeter, and AC is equal to 35 Newton per mm square, 3.5 centimeter, towards right of A. Why we have to draw towards right of A? Because both are tensile. If one is tensile, another is compressive. For example, if sigma x is tensile, you have to plot sigma x on right side. Sigma y is compressive, you have to take it to left side. That is the mean. Then second step, draw perpendiculars at B and C. You have to draw a perpendicular here at B as well as at C. Those perpendiculars should have the value of tau. That means 25. You can see here 25, 25. So AB is sigma x, AC is sigma y, CG and BF, they are tau values. So one side you take above that, another side you take below that. So please understand here. So you have to draw two ordinates at A and B such that they represent the shear stress values, tau values. So and cut off. So what they have written here, and cut off BF and CG. So this BF should be equal to 25. CG also should be equal to 25. Only thing is they are on opposite sides. This is above that line, this is below the line, but they are of same length. So that is the second step. So now you got 2 points here. What are the 2 points? G and F. And all these things you have to draw on a graph sheet. So you got 2 points G and F. Join the points by a straight line. Join this GF. It will cut somewhere here at O. The horizontal line is cut at some point O here. Okay, so this is the third step. So first step, draw AB is equal to sigma x, AC is equal to sigma y. Second step, draw CG is equal to BF is equal to tau is equal to 25 Newton per mm square, that is 2.5 centimeter. Third step, join the points G and F by a straight line. It intersects the horizontal line at the point O. Next, what you have to do is, taking O as center and OG as radius. OG or OF, both are equal here. This hypotenuse, in this triangle, that is the hypotenuse. So taking OG or OF as radius and O as center, draw a circle. See, like this. Draw a circle. So this radius of the circle is OG or OF. Center of the circle is O here. So this circle is called as the Mohr circle. This circle is called as the Mohr circle. So 4 steps are over now. So draw AB and AC first. Second step, draw CG and BF. Third step, join GF. Then fourth step, taking this O as center, OG or OF as radius, draw a circle which is called as the Mohr circle. Now, once you draw that circle, you can see here it cuts at 2 points, L and M. That circle cuts the horizontal line at 2 points. So observe here, L and M. So this is called as the bigger one, AM. That you measure the distance AM here. So once the Mohr circle cuts the horizontal at 2 points, L and M, measure this AM using scale. Okay, so that AM gives the major principal stress, AL gives the minor principal stress. So AM is sigma 1, AL is sigma 2. So this is what the procedure is for finding the principal stresses. Next, what he has asked for the same problem, what he has asked is, he has asked what is the normal stress and shear stress on this oblique plane. To find that, what you have to do is, now after this Mohr circle, you take this line, that is GF line. From the GF line, measure an angle 2 theta. So here this angle is theta. Theta is 45 degree here. Please note that. Theta is given as angle of oblique plane is 45 degree. Please note that always this angle is measured with the vertical. With the vertical. So if they give this angle, you have to take 90 minus of that. Okay, that becomes the vertical. Always this angle is measured with the vertical line. Now this, if you take it as theta, 2 theta will be 90 degrees. This is 45. So 2 into 45 is 90 degree. Now to get the normal stress and shear stress on the oblique plane, what you have to do is, you draw a line which makes an angle of 90 degrees in the anti-clockwise direction. This is very important. Not like this. So GF, from the GF line, take 90 degrees in the anti-clockwise direction. Draw a line. So this is 90 degree. That line OE cuts the Mohr circle at E. Cuts the Mohr circle at E. Okay. Then join this AE. Join this AE and draw an ordinate at E. That is ED. ED is the ordinate. AE is the hypotenuse. Now once you get that triangle, so this in this triangle ADE, this AD represents the normal stress, DE represents the shear stress on the oblique plane. On the oblique plane, and this AE represents the resultant stress. Resultant stress is square root of normal stress square plus shear stress square. All those we have done. That AE represents the shear resultant stress. So in this problem, so I had explained you how to find the major principal stress, minor principal stress, as well as normal stress and shear stress acting on an oblique plane, making an angle theta with the vertical. So once again, I am going to explain. All of you be attentive. So this sigma x is given as 65 tensile, sigma y is given as 35 tensile. And he has asked what is the normal stress and shear stress, or it can also be called as direct stress and tangential stress, acting on an oblique plane, which makes an angle of 45. What we have done, since both sigma x and sigma y are tensile, we had to plot the points on one side, right side only. Choose a point A on the graph sheet, extreme point. You can take to the here to measure 6.5 centimeters, because I have taken the scale. 1 centimeter is equal to 10 Newton per mm square. 65 means 6.5 centimeter. That is the scale for sigma x. So measure 6.5 centimeter on, which is 35, 3.5 centimeter. So that sigma y, since both are tensile, we are plotting on the same side. If it is compressive, we have to plot on the other side. Left side we have to plot. You have to extend like this. But then A cannot be taken at the extreme left. It has to be started from somewhere here. So AB is sigma x, AC is sigma y. Then first step is over. Second step, draw ordinates CG and BF equal to shear stress value along the y direction. So shear stress and the normal stress, they will be acting at right angles to each other. That is why normal stress is represented along x-axis, shear stress is represented along the y direction. Be careful there, because they are mutually perpendicular to each other. So stress values, normal stress values are represented on the x-axis, shear stress values are represented on the y-axis. So second step, draw CG is equal to BF is equal to tau. 25 means 2.5 centimeter. Keep it in mind that at one point it has to be drawn above, at the other point it has to be drawn below, because shear forces will be acting in opposite directions like this. If we consider two edges, if it is given like this here, it will be like this here, and it will be like this here, it will be like this here. That's why we have to plot the shear stress in the opposite directions, above and below the x-axis. That is second point. Third step, join this point GF, these 2 points, G and F. It will cut at some point O. That is the third step. Fourth step, keeping O as center, O draw a circle. So this circle is called as the Mohr circle. Mohr circle of stresses. In general, it is called as Mohr circle of stresses. Now, once that Mohr circle is obtained, now that Mohr circle will cut at 2 points. The x-axis M and L. See here, it is cutting the x-axis at 2 points M and L. So AM is the major principal stress, AL is the minor principal stress. So my major principal stress is denoted as sigma 1, minor principal stress is denoted as sigma 2. So here both are tensile. So how do you say that it is tensile? It is positive, because if the point is right side of A, it is positive. So both are positive here. So if you have to measure this, AM and AL you have to measure. Of course, in this problem, What is the value? See here. Of course, that value he has not given. Anyway, you can, if you measure that, you will get that value. Then, what else he has asked? He has asked another thing: normal stress and shear stress on an arbitrary plane, oblique plane, making an angle 45 degree with the vertical. So for that, what you have to do is, from this line GF, measure, you draw a line which makes an angle of 2 theta, that is 2 into 45, 90 degree in the anti-clockwise direction, like this. See, you draw a line, so this angle between this OF and OE is 90 degrees. So that line will cut the Mohr circle at point E. So now draw an ordinate at E. ED is the ordinate at E. This ED represents the shear stress. AD represents the normal stress on this plane. So on this plane, you will be having a normal stress like this and shear stress like this. So this normal stress acts perpendicular to the plane. Shear stress acts tangential to the plane. So that value is sigma n and sigma t. Sigma n here is AD, sigma t is ED. And this AE is there, This AE is nothing but the resultant stress. AE is the resultant stress acting on the oblique plane, which is nothing but square root of AD square plus DE square as per Pythagoras theorem. So this is what, suppose if they give, let us say for the same problem, if they give instead of 45 degree, if they give 30 degree here, 30 degree, then the only change here is after drawing the Mohr circle, this 2 theta, so this angle we have to take 60 degrees because that angle is 30 degree. We have to take 2 theta, 60 degree, draw a line which makes an angle 60 degree with this line in the anti-clockwise direction, and somewhere here it will come. So E will be somewhere here. So then draw an ordinate at E like this and join that point E to this A. So in that case, the ED becomes this. So this becomes your shear stress. AD becomes the normal stress on the oblique plane. And this AE is the resultant stress. So like that you have to find. So in this problem, then another thing is this Mohr circle cuts the horizontal line at 2 points L and M. So this larger one, AM. So this is called as the major principal stress. AL is called as the minor principal stress. You have to make, anyway you are drawing on a graph sheet. You will be knowing what is the distance between these two. Convert that into that using that scale. You multiply that by 10. You will get in Newton per millimeter square because we have taken 1 centimeter is equal to 10 Newton per mm square. So he has given the answer here in this problem. You can see this is the answer. Answer you have got, so you see here 75 Newton per mm, so that means 7.5 centimeters. You have got that length of AD as 7.5, length ED as 1.5. So AD 7.5, ED 1.5. That means this one. AD 7.5, ED 1.5 means this is normal stress, this is shear stress. So convert that centimeter to stress value. You know that 1 centimeter is 10 Newton per mm square. Therefore, 7.5 centimeter becomes 75 Newton per mm square, and 1.5 centimeter becomes 15 Newton per mm square. So that is by graphical method. So if you measure this AE, that will be equal to square root of that 75 square plus 15 square. Naturally, you should get it. Analytical method by using the formula. So this is the formula for finding sigma n and sigma t. So sigma n is the normal stress on that oblique plane. Sigma t is the shear stress on the oblique plane. So you can just use this formula also. Please note that here sigma x is 65, sigma y is 35. So if you substitute in that, theta is 45 degrees. If you substitute in this formula and if you simplify, you are going to get the same answer, 75 Newton per mm square. That is by analytical method. So in the exam for 10 marks, they can ask both analytical method also using the formula. So graphical method, analytical method, both you should be knowing. So the tangential stress formula is this. Substitute the value and check. So you are going to get the same answer, 15 Newton per mm square. So this is how we can find the uh, normal any oblique plane given in a two-dimensional stress system. Okay. Now let us see this. Okay. So that is the second type of problem. In this case also, this AM gives the major principal stress, AL gives the by 10. Suppose if it is 2.5 centimeter, this AL is 2.5 centimeter, so 2.5 into 10, that is 25 Newton per mm square. That is the minor principal stress. Suppose if this is 8 centimeters, so 8 into major principal stress, both are tensile. So another problem, let us check here. An elemental cube 10 and shear stress 10. Draw the Mohr circle of stresses and find the magnitude and direction of principal stresses and the greatest shear stress. Greatest means maximum shear stress. Okay. You can do by Mohr circle method. Then you can check it by analytical formula also. Now here, see here, same procedure we have to follow. Take a point A here. Sigma x is 30, sigma y is 10. Both are tensile here also. You can choose some scale, 1 centimeter of the stresses given. You can, so sigma, now sigma x, I will got as sigma x. Sigma x becomes 15 centimeters, sigma y becomes, tau becomes 5 centimeters. Okay. Now take this, draw a horizontal line, measure A means how much centimeters we have to take? 15 centimeters we have to take because we have chosen a scale of 1 centimeter is equal to Q Newton per mm square in both x and y directions. You have to choose the same. Shear stress is represented in the y direction. That is the concept here because they are mutually perpendicular to each other. So AB is 30, that is 15 centimeters. A that is 5 centimeters. You have to draw 5 centimeters. That is the first step. So AB and AC. Then equal to 10. 10 means 5 centimeters. Shear stress. So 5 centimeters, 5 centimeters. You have to draw. Then join this GF. Join this GF. It will cut at some point O. Radius. Draw a circle. This is your Mohr circle of stresses. Mohr circle. So that circle will cut at 2 points L and M, the horizontal line. AM is the major principal stress, AL is the minor principal stress. Okay, that is the thing. And this line, whatever this line is there, with the horizontal like this. This is 2 theta. So you can measure this angle here on the graph and measure the angle. So 2 theta, suppose if 2 theta is 40 degree, then theta will be 20 degree. So you have to measure that theta there. So 2 theta will be 25 degrees. That is the direction of one principal plane. Another principal plane will be the 25 plus 90, 115 degree. So this angle gives the 2 theta gives the nothing but the direction of principal plane. To measure the 2 theta, whatever theta you are going to get, that is the direction of one principal plane, and add 90 degree to that, you will get the direction of another principal plane. So that is the answer, that's all. So I will explain once again. Draw AB equal to 30, that is 15 centimeters. AC is equal to, that is 5 centimeters. First step. Draw CG and BF in opposite directions, because one is positive, another is taken as negative. So which is equal to 10, that is 5 centimeters. Then that is the shear stress. Then join this GF, taking O as center, OG or OF as radius. Draw a circle called Mohr circle of the stresses, which cuts the horizontal line at 2 points L and M. AM, measure this AM distance, convert that into stress value. Distance should be converted to stress value by multiplying by 2. Then that is your major principal stress. Measure AL, convert it into Newton per mm square by multiplying by 2. It gives minor principal stress. Then measure this angle. This angle becomes 2 theta from the horizontal to this line. Divided by 2, you will get theta. Suppose if theta is 25 degree, direction of principal plane, one principal plane. Add 90 to that, it gives the direction of another principal plane. Principal plane means shear stress is 0, because x-axis represents normal stress. And in this problem, one more is asked, greatest shear stress. Greatest shear stress means maximum shear stress. So maximum shear stress, draw an ordinate. Ordinate means vertical line which cuts the circle. It is cutting at H. Measure this OH. This length of OH, multiply it by 2, because convert that distance to stress value. That gives the maximum shear stress. This is the maximum value. Radius of Mohr circle itself gives the maximum shear stress. Please note that radius of Mohr circle gives the maximum shear stress. So this is what we can see in this. Of course, he has done it here. See here, everything has been done here. So what I advise you is today you practice these two problems, whatever I have explained. Mohr circle. So tomorrow I will be explaining another one or two problems on this. So these are the equations you should remember for using. So if you are calculating maximum shear stress using analytical method, you are going to get the same answer. So you should know both sets to find the principal stress, principal plane, as well as normal stress and shear stress as on an oblique plane. So both the types of problems I had explained, but in both the problems I have taken sigma x and sigma y, both I have taken tensile. So tomorrow I will take up a case where is one is tensile, another is compressive. How to do that problem I am going to explain you tomorrow. Okay. So practice today these two problems on a graph sheet and check your answer using the formula, both the methods. So this is known as the graphical method of finding the compound stress or the principal stresses or stresses on an oblique plane using Mohr circle of stresses. Okay. So what you can do is, for the problem which we have done earlier using analytical method, for the same problems, you can practice Mohr circle method. So then it will be, because anyway you'll be knowing the answers, or it will be easy for you to check the answers by graphical method. Okay. So tomorrow we will take up some more problems, and some two small theories are there. Theories of failure, that also I am going to explain tomorrow. So if I do that, then this module 2 also will be over. So I'll take the attendance. Eighteen 28. 18028. 30.
Yes, sir.
19002.
Yes, sir.
3.
Yes, sir.
5.
Present, sir.
6.
Present, sir.
7.
Present, sir.
9. 9. Okay.
Present, sir.
13. Okay. 13.
Sir, CV00 I'm present.
Okay. Okay. 13. Medesh.
Present, sir.
Yes. Okay. 14.
Present, sir.
16. 16. 17.
Present, sir.
19.
Present, sir.
Okay. So tomorrow I'll take up some more problems. Tensile and compressive together. Huh? Okay.
In